So today, the next project that we're working on is called aggregation. Okay, aggregation and collision. So those two words are not, they don't have the same meaning. They're very, very different meaning. But formally, they're sort of related to each other. Okay? Aggregation means to bring together many pieces. Okay? So whereas the design that you just recently worked on was taking one piece and subtracting from it to make a design, the next project is about creating a design from a lot of parts. Okay? And they're going to have very, very different visual characters, one from the other. So aggregation and collision. So we're going to talk first about ways of aggregating forms, right? And then we'll talk, I'll try and give you a demonstration on what it is to collide two things. Okay? All right. So I'm going to start with this set of boxes right here. This set of boxes have a coplanar, they have a face-to-face connection. Okay? So this face and this face are connecting to each other. They have coplanar surfaces, right? That means that this plane and this plane are both in the same plane, as are these, and these. So this has one face-to-face connection and 4 coplanar surfaces. Actually, it's 8 coplanar surfaces, not 4. Okay? One of the problems with this, right, if you are trying to express this idea of aggregation of something that is made from many, many parts, is that that can very easily be confused as one bigger rectangle, right? Okay. So when you have face-to-face connections with coplanar surface conditions and collinear edges, right? So this edge and this edge are both collinear. They're both in the same line. This edge and this edge are both collinear. Coplanar, face-to-face, collinear. Huh? Did you have a question? Okay. So this does not express the idea of making something out of lots of parts. So let's take a look at it at a different condition. What if we take this one and we slide this one forward? For those of you that are sitting over there, maybe I'd do it the other way, like that. Now, this still has a face-to-face connection, but it has less coplanar faces. Now there's only 4 coplanar faces. Okay? And it has only a couple of collinear edges. These edges are no longer collinear, whereas in this one there's a lot of collinear edges. They're both in the same line. That's what collinear means. Okay? So this is the second condition. This one is a little bit better than this one, but still, it still looks like it could be one object that has a corner removed and a corner removed, right? So if I was to draw that as a diagram like this, right? If I take 2 pieces and I put them next to each other like that, right? Like that, they could read as one big fat thing like that. Likewise, if I take one and I stagger it back from the other, it does a better job of seeing that there's 2 items, but it can still feel like it was one object that had the corners removed from it. So this little part got cut out and this part got cut out, but that was the original rectangle. It was a big rectangle, right? Okay, so now we go to the third condition that I'm going to kind of bring forward to you, and that's going to be where we take 2 pieces and we make them so that they are shifted from each other, but then we raise one of them up. Okay? So now in a situation like this, right, it becomes hard to dismiss the fact that there's two volumes there. Is that right? How many coplanar faces, how many face-to-face conditions do we have? We have one partial face-to-face condition. How many coplanar faces do we have? None. Other than the face-to-face condition, which could be considered coplanar, there are none. Right? Likewise, there are very few, if any, collinear edges. I mean, that and that, where the face-to-face condition is, could be considered collinear. Right? But when we get to this one, all of a sudden, hey, it's clear that this object is made from two parts. This one could be, or it could be one part that had a corner and a corner removed from it. This one is completely ambiguous. You can't tell whether it's two pieces or one big piece. Okay? And that brings us to the collision part. Okay? So far, none of these have engaged each other, correct? None of them have collided with each other. They're just sitting adjacent to each other. So when we speak of collision, one of these is going to be shifted back, right? Then shifted up, but then it's also going to be pushed into the other one. So let me find an example of one. I'll do it for you in this one. But let me find an example of it. These are aggregated and collided volumes. Okay, now these have no coplanar faces. They have no collinear edges. Everything reads as three different parts. So if I was to take this one and this one, I shifted it back, then I shifted this one up, and then I cut this one away to where this one could move into that one, I now have an aggregated and collided form. Okay? And I'll actually do that with this one to kind of give you guys an idea of like what it looks like. All right? Any questions about that? So it becomes really important that you guys kind of get that verbiage down so that you can have that dialogue with me. Okay? Yes?
Which one of these like relationships between the shapes, which one considered like more appropriate for design as in real life? Like this
that depends. There's no, in design there generally is never a one answer fits all. For the purposes of expressing a building that is made of many pieces, the right answer is this one.
Because they are like more they are interacting more, like the shapes, they are interacting more with each other, and
it's not that they're acting more with each other, it's that you can clearly see where one ends and the next one starts.
Oh, so we can like we can know like the definition of the shape itself. It doesn't lose the shape.
It does not lose its shape. Whereas this one, right, not sure. It could be two things, it could be one thing.
Yeah.
This one for sure, right, could be one or two.
Yeah.
This one is a little less ambiguous, but still, you know, it doesn't have quite the definition because the edges are not, some of the edges do overlap. And finally, the last one, which is like this, right? You don't end up with any collinear edges and no coplanar faces and no face-to-face connections. Okay? For your design that you'll be working on today, you are allowed to have face-to-face connections, but you're not allowed to have any collinear edges, and you are not allowed to have any coplanar faces on two objects that are touching each other. Let me explain what I mean by that. So let's say, these are the actual pieces that you guys will be working with. Let's say that I have a bar-like element that has three of these attached to it. Okay? So there is a face-to-face connection here, right? There's a face-to-face connection here, and there's one face-to-face connection here, correct? But there are no collinear edges. And there are no coplanar surfaces that are in direct contact with each other. That's important, because if I put these two together, now there are coplanar surfaces in connection with each other. But as long as they're separated like that, right, these faces here are allowed to be coplanar because you still read the entirety of each object. Does that make sense? Okay, all right, let's stop that video.